In this lesson, we will learn how to prove that two lines are parallel, as well as to state and apply the fact that through a point outside a line, there's exactly one parallel line and one perpendicular line to the given line. Now in the last lesson, we learned 4 different properties of parallel lines. And this lesson is pretty much the same thing that we just did. So if you understand the last lesson, this lesson should fall into place pretty quick. Because all we're doing is we're dealing with the converse of those properties. Where property 1 said if two parallel lines are cut by a transversal, then the corresponding angles are congruent. Whereas the converse would be switching the if and the then statement. So now in this lesson, all we're saying is that if the corresponding angles are congruent, then the two lines are parallel being cut by a transversal. So we just switch the if and the then statement. Property 2 says that if two parallel lines are cut by a transversal, then alternate interior angles are congruent. Whereas the converse says that if the alternate interior angles are congruent, then the two lines are parallel being cut by a transversal. So far we have 2 ways that we can show parallel lines, with the alternate interior angles being congruent, as well as with the corresponding angles being congruent. The third property says that if two parallel lines are cut by a transversal, then the same side interior angles are supplementary. The converse says that if we have same side interior angles that are supplementary, then the two lines are parallel and are being cut by a transversal. So notice so far everything has been identical to the previous lesson. We're only switching the if and the then statement. The fourth property is not quite the same. It's not a true converse of the original statement, but it's kind of the same. Where property 4 says if the transversal is perpendicular to one of the parallel lines, then it is perpendicular to the other parallel line also. And the converse kind of is if two lines are perpendicular to a third line, then the two lines are parallel and are being cut by a transversal. So that is a fourth way that we can show that we have parallel lines, by showing that two lines are perpendicular to a third line. So what we have are ways to prove that two lines are parallel. Way 1 is to show that a pair of corresponding angles are congruent. The second way is to show that a pair of alternate interior angles are congruent. Third way is showing that a same side interior angles are supplementary. The fourth way is where we show that both lines are perpendicular to a third line. And there's actually one more way that we're going to discuss that is not one of the properties from the previous lesson. And that is that if we can show that both lines are parallel to a third line, then we have two parallel lines. So here we have a line and then another line. And we're trying to prove that these two lines are parallel. Well, if we have a third line right over here, and we found that line 1 is parallel to the third line, and then we conclude that line 2 is also parallel to that third line, then by kind of like the transitive property, we can conclude that line 1 and 2 must be parallel to each other as well. So if both line 1 and 2 are both parallel to line 3, then we can conclude that line 1 and 2 are parallel with each other. So now we have 5 ways to prove that two lines are parallel, and from here we're going to use that information to show or try to prove that two lines are actually parallel. So here we have an example. We're trying to name the parallel segments assuming that only measure of angle 7 is equal to measure of angle 3. So if that is all we knew, the question is what two segments, if any, are parallel. So if we look at angle 7 and angle 3, angle 7 is here, angle 3 is here. What I want to do to answer this question is figure out which segments or which lines are creating those angles. Well, to create angle 7, we need this line up here and then this line cutting across. Those two lines would create angle 7. And now we need to do the same thing with angle 3. what two lines create angle 3? Well, the one we just drew, line SC, would be one of them, but then we also need line CK. So those two lines would create angle C. So from here we need to determine if and how are angle 3 and angle 7 related. Well, notice that if any of these lines are going to be parallel, it would be the top and the bottom, AS and CK. But to prove that, we need to have angle 3 and 7 being either alternate interior angles, corresponding angles, or same side interior angles that are supplementary. Well, angle 3 and angle 7 would be alternate interior angles because they're on opposite sides of this transversal cutting through, and they are also interior. They're on the inside of the two lines on the top and the bottom. So angle 3 and 7 are alternate interior angles. We know that they are congruent, and one of the ways that we can prove that we have parallel lines is by showing that alternate interior angles are congruent. So because of that, we can conclude that we have parallel lines. The lines that are parallel are the lines that we see here in red. Angle AS line AS and line CK. So those would be parallel. And the one property says that we need congruent angles, and here we have equal angles. Don't forget that angles that are congruent are the same thing as angles that have equal measure. So that is the same thing. Next example, same picture, but now we have measure of angle 8 and measure of angle 4 being equal. So angle 8 is right here, angle 4 is right here. So the question is, which segments or which lines create those angles? So angle 8 is created by SK and then SC. Then angle 4 is created by SC and AC. And if any lines are parallel, it's going to be the right side and the left side, the ones we have highlighted in red. But the question is, can we conclude that? Well, angle 8 and angle 4, the question is, how are they related? Are they alternate interior, same side interior? What are they? Well, they're both on the interior of these two lines right here on the sides. They're on the inside of those, and then they're on opposite sides of this transversal that's cutting through. So they're alternate interior angles. And we have alternate interior angles being equal, and that is one of the ways that we can prove that we have parallel lines, is if alternate interior angles are congruent or equal. So therefore, SK and AC would be parallel. In this next example, we are told that measure of angle SAC plus measure of angle ACK equals 180. And the question is, which lines are parallel, if any? So here we have SAC. That is going to be this angle from S to A and then down to C. So this angle, and then plus measure of angle ACK. So ACK would be from A to C down over here to K. So we're looking at this angle right here and this angle down here. And it may be helpful to extend these lines a little bit so we can picture what is happening. So let's extend this. And the question is determined on how are these angles related. Well, notice if we have parallel lines, it's going to be SA and CK. But the question is, can we conclude that? Well, angle SAC up in the top right corner and ACK the bottom right corner, those would be same side interior angles. So those are same side interior, and we are told that they add up to be 180 degrees. Well, is there a property that says that if we have same side interior angles that are supplementary, then we have parallel lines? Well, the answer is yes. That is one of the properties that we have. And so therefore, because we have same side interior angles that are supplementary, adding up to 180, then we do have parallel lines, where SA, the top line, would be parallel with CK, the bottom line. Here's one last example. where you're told that angle 7 is congruent to angle 4. So angle 7 is here, angle 4 is right here. So angle 7 is created by this line, AS, and then the line SC. And then angle C is created by SC, and then AC right here. And so looking at the only 3 lines that are being used, we can tell automatically that there's no lines that are going to be parallel, because every line intersects with each other. So we can already tell without analyzing further that there would be no parallel segments. And now we're going to switch gears a little bit and just look quickly at 2 different theorems that you need to know. And so theorem 1 is still dealing with parallel lines, and it says that through a point outside a line, there's exactly one line parallel to the given line. So for example, if here we have a line and a point not on the line, and you were to draw a line that goes through this point and is parallel to this line, there's only one line that we can draw through that point that is parallel, and it would look like this. And the second theorem says that through a point outside a line, there's exactly one line perpendicular to the given line. So same picture, the only difference is now that we are saying that there's only one line perpendicular as opposed to parallel. So if we try to draw a line perpendicular to the given line through that point, there's only one line that would fit that description, and it would look like this. So this would be perpendicular, or making a 90-degree angle down here, and there's only one line through that point that would do that. If you try to draw other lines through that point, they would not be perpendicular. They would be some different angle. And that concludes our lesson for today. We will see you next time.